Today we will be talking about a comparison of dairy waste to energy methods for methane emission reduction in California. I'm Blanca, and Cassandra and Danny are also here talking about this project. Um, so first of all, our motivation for this project is basically that dairy farms in California are responsible for 44% of the state's methane emissions, and this is an equivalent to 40 million metric tons of carbon dioxide. Particularly, the methane or the waste management processes at these dairy farms are responsible for um, toxic emissions of methane into the atmosphere, which contribute to global warming. So, particularly, we want to find ways to tackle these methane emissions, reducing them, and having more positive impacts on the environment. So in this project, we will be discussing ways of converting these dairy wastes into a usable energy and thus reducing the methane emissions that would be there from just letting the manure sit. The three methods we will be comparing are anaerobic digestion, pyrolysis, and hydrothermal carbonization. Anaerobic digestion, AD, is a process that uses microorganisms to produce a biogas that has valuable qualities for producing energy. HTC and pyrolysis are both thermochemical methods that convert the waste into usable energy. Namely, both of them have char and gas byproducts, and pyrolysis also produces a useful bio-oil that has energy applications.
To analyze the sustainability of these methods, we broke down the different pillars of sustainability, environmental, economic, and social, into different indicators. In environmental, we had methane prevention, global warming potential, energy consumption, and water contamination. For economic, we used higher heating value, the operation costs, scalability of the process, as well as waste disposal. And for social, we looked at the job creation potential, as well as health and safety related to the process. To better analyze this, we created a multi-criteria framework that had scales from 0 to 1 that we assigned each indicator. 0 was the least sustainable option, and 1 was the most sustainable. If it fell somewhere in between, we aggregated the scores based on the importance of it and chose the highest score as the most sustainable method.
Getting into our results, pyrolysis scored the highest for the environmental indicators, and a big factor in this was because the biogas produced in pyrolysis can be recycled back to power the plant, which significantly lowers the energy consumption indicator. And AD and HTC scored a bit lower but are pretty evenly matched. Next, moving into the economic analysis, again, pyrolysis scored the highest, and a big factor was the fact that biogas can be recycled, which lowers operational cost. AD scored the lowest because although it has the lowest operational cost, it also produces the least amount of valuable product. And lastly, our social analysis indicated that HTC was the most sustainable in this regard, particularly because it's a new emerging technology that has a lot of potential in terms of job creation, and from a health and safety perspective, it's the only method that doesn't have the potential to release toxic gases. And here we can see our total aggregated scores for all methods. AD scored the lowest with 4, pyrolysis scored the highest with 6.415, and HTC is a close second at 6.354. In comparing our total scores, our analysis ultimately indicated that pyrolysis is the most sustainable method to conduct waste to energy conversion in the dairy industry. Thank you so much for listening to our presentation.